Alright, so the problem solving process we did in the last video, we're going to apply these to sinusoidal models and word problems. So it says this particular person, don't want to mispronounce his name and make him upset, is riding a Ferris wheel, models his height in meters above the ground, t seconds after the ride starts. Alright, so t is in radians. Alright, so right now it says, when does he first reach a height of 16 meters? So when you're solving these problems, it's going to be very, very easy. All you got to do is you're going to take this 16 meters because it says h of t models his height. So we're just going to plug in right here. We're going to plug in a 16. So we're going to put 16 equals negative 10 cosine 2 pi over 150 t, close the parentheses, and put plus 10. Alright, so 2 pi over 150 t plus 10. Now, when we're solving this, alright, here's our equal sign right there. So the first thing I'm going to do is I'm going to take away a 10 from this side, and I'm going to take away a 10 from this side. I'm going to get 6 equals negative 10 cosine 2 pi over 150 times t. Alright, getting closer. Next thing we're going to do is we're going to divide both sides by negative 10. Just like that. And 6 divided by negative 10 is negative 3/5. You could still keep it as negative 6 over 10 if you wanted to. Equals the cosine. Move this over a little bit. Thinking ahead here, going to move that over just a little bit because we're going to apply the inverse of cosine here. Times t. Now, what we have to do to both sides is we have to apply what's called the inverse of cosine to this side, and we're going to apply the inverse of cosine to the other side. And these will cancel each other out. So all we're left with now is a 2 times a pi all over 150 times t equals whatever value I get for the inverse of cosine of negative 3/5. Now this is in radians, so we're just going to use this. We're going to go over here in radians. There's the function right there. All right. So what we're going to do is we are going to take the inverse. So here's our functions. We're going to take the inverse of cosine and do negative 3 divided by 5. And there's our answer in radians, 2.21. So we're going to take 2.21. Make sure, don't do degrees, make sure you're in radians. Degrees would mess things up. So there we are in radians, 2.21. So I'm going to say that's approximately equal to 2.21. It says nearest whole second, so we should be okay. Now the last thing we're going to do to solve for t is to multiply both sides by the reciprocal of 150 divided by the product of 2 times pi. 150 all over 2 pi. Just like that. And we're going to find out whatever that approximate answer is, and we're going to trust it, and we're going to type it in, and we're going to see if we got it right. So, I'm going to go over here to my handy-dandy calculator. I'm going to take 2.21, open the parentheses, put a little division bar, put the 150 up there, and the 2 up high down there. And it looks like it says 52.75 seconds. All right, 52.75 seconds, which is going to put me at 53 seconds rounded to the nearest whole seconds. All right, so now I'm going to zoom out just a bit here. All right, and what we're going to do is I've kind of typed in our function right here that's at negative 10 cosine plus 10, all that stuff. Just type that in right here. I'm going to delete this. I'm going to delete this. And I'm just going to say y equals 16. And oh my goodness, we got 52.86 right here, which is basically what, 53. Now why is that answer different than ours? Because remember, I rounded mine. I rounded mine to 2.21. I didn't multiply it by everything. But we'll still get the same answer, which is 53 seconds. So I'm going to go over here. I'm going to type in 53. Cross my fingers. Woohoo! We got it. All right. All right, three more. Three more. All right. Hungry Harry is a giant ogre with an appetite that fluctuates throughout the day. H of T models the weight of sheep that Harry would like to swallow. T hours after he wakes up. Here, T is entered in radians, so we have our function. What is the second time after Harry wakes up that he feels like consuming 17 kilograms of sheep? Oh, not the first time, but what is the second time after it? All right, so what we're going to do is we are going to go ahead and plug in 17 kilograms right there for 17. All right, and then what we're going to do is we're going to figure out the length of the period, all right, and figure out how long will it take for him, not just the first time, but the second time throughout the day. But then we're going to type it into Desmos. We'll be able to see if we did everything correctly. All right, here we go. 17 equals 12 times the sine 2 pi over 24. Oh, looks like our period is going to be 24 hours. Interesting. Okay, all right. Plus 15. All right, so step number 1, going to take away 15 from both sides. Exciting stuff here. 17 minus 15 is 2. Equals 12 times the sine of 2 pi over 24, which is just pi over 12. You could also do pi over 12 if you wanted to. All right, next thing we're going to do is we are going to divide everything, divide both sides by 12. All right, and 2 divided by 12 is 1 over 6 equals sine. I'm just going to put, oh, I forgot to put a t right here, sorry. T, probably saying, you forgot the t. All right, I remembered, there we go. Pi over 12 times t, close parentheses. Now this is where we need to take the inverse of sine. So that's what we're going to be doing next. We're going to take the inverse of sine on this side. And we're going to take the inverse of sine on this side, so those cancel out. And we are left with pi divided by 12 times t equals whatever this ends up becoming. So we're going to go ahead and do, clear that out, clear that out. Let's see here, sine, inverse of sine, let's do 1 divided by 6, go, 0.167, that should be enough, but 0.167, alright, 0.167. Then, to solve for t, alright, to solve for t, what we're going to do to both sides is we are going to multiply both sides by the inverse, which is 12 over pi. 12 over pi. And we are going to get an approximate value. So let's go ahead and do that in our calculator. All right, you know what? I'll also go up here, just take this whole thing, take the inverse of sine of 1 divided by 6. All right, just kind of go over here to the right. All right, and multiply that by 12 over pi. Ooh, 0.6396. All right, let's go do that. All right. 0.6396. So that's the time that's going to take for the ogre, all right, to want to consume 17 kilograms of sheep. But we got to figure out the second time. This is where it gets a little bit trickier. So let me kind of show you the concept behind the unit circle, all right? And before we did everything, we found the inverse. Before we multiply both sides by 12 over pi, we had the inverse of 1 over 6. All right, so what does that actually mean if we're looking at the unit circle? And probably the best way for me to describe it is actually think about degrees and then kind of convert it to radians. So here we go. I'm just going to build a quick little unit circle. Hopefully this will help you understand. If I went back over here and I typed in the inverse of sine, and I did 1 divided by 6, and I went over here and I changed it to degrees, you can see that's about 9.6 degree angle, a 9.6 degree angle, which means we have a really small sliver of an angle. So I'll make a little triangle right here. Let's pretend this is a 1, that distance is 1, and that's 6, and then we have theta right there, there's theta. Alright, so that theta right there would be about 9.6 degrees. And that would be the first time. But the second time, what's the other place that it could also be at that same exact angle of theta where it's at 9.6? Well, the second time, is actually, we're going to do 180 degrees minus 9.6 degrees, which is 170.4 degrees, which basically means from here all the way to right there would be 170.4 degrees. But in terms of radians, that's going to be pi. So what I'm going to do, let's watch this, I'm going to take pi, I'm going to subtract whatever we get for the 0.167. So I'm going to do that in the calculator right now. I'm going to do pi minus 1.67, and I get, not 1.67, sorry, 0.167, that's better. And I get 2.97, we'll say 2.975, 2.975. All right, and we get 2.975 radians. That's the approximate value. That'd be the approximate value that's close to this 170.4. So, what do I do with that? So here's what I want you to see, what I'm going to do. I'm going to take that, and instead of multiplying 12 over pi times 1.67, I'm going to multiply it by this, and that should give me my second time. So, I'm going to take, right here, the pi minus, and I'm going to do the whole thing here. I'll do the inverse of sine of 1 divided by 6. So take that, I'll try to make it as accurate as I can, and I'm going to multiply that by 12 divided by pi. And I get this 11.36. Now what I've done up here, is I've typed in the function that we started with right here. I've said y equals 17, and you can clearly see right here, the first time the ogre's hungry is 0.64, but the second time that he's hungry is 11.36. Alright, so if you wanted to, obviously, if you're trying to get good at being able to interpret what it's asking me to do, if I had to do it by hand, this is how I would do it by hand. If I had access to a graphing calculator, this is how I would do it in the graphing calculator. So 11.36 seconds. 36 hours, 11.36, right into the nearest tenth of an hour. So the nearest tenth of an hour, 11.4. And that's what I'm going to type in here, 11.4. Cross my fingers, hope to die. Yay! Didn't die, good. Alright, let's go on to the next problem. So our next problem is dealing with Luisa jumping on a trampoline, which h of t models her distance above the ground in t seconds after she starts jumping. It says, what is the second time when she reaches a height of 1.2 meters? All right, what's the second time? So first thing we're going to do is we are going to plug in 1.2 right in here for the height. 1.2. And we are going to set it equal to negative 0.6, which is negative 3/5. Cosine. Put 2 pi over 2.5. We'll put letter t plus 1.5. There's our equal sign. Alright, first step, what we're going to do is we're going to take away 1.5 from this side, and we're going to take away 1.5 from this side. We get negative 0.3 equals negative 0.6. Okay, there we go. Alright, so this will be a pretty easy one to kind of have a nice, neat little number, a little fraction to work with when we divide both sides by 6/10 and divide by negative 6/10. Those will cancel out. This will become a 1/2. Nice. So basically, here's what we have left. All right, we've got a cosine of this fraction. All right. Right here. And we have it equal to 1/2. There we go. So when you guys are thinking of this fraction of 1 over 2, you know we're going to have to be taking the inverse of cosine of both sides, right? So we have the inverse of cosine on this side, and we're going to apply the inverse of cosine on this side. So these cosines will cancel out. We have 2 pi over 2.5 times t equals the inverse of cosine of 1 over 2. Now, this is part of the special right triangle of 30, 60, 90. In degrees, this would become, if we were to do the inverse of cosine, 1/2, that would equal 60 degrees. All right, so right here, if I did this inverse of cosine, I did 1 divided by 2, and I was actually in degrees, you would see that's 60 degrees, but we're going to convert it to radians, which actually is going to become pi over 3. This little decimal right here is pi over 3. See, pi over 3. So in radians, it's pi over 3. Just remember, if you want to convert degrees to radians, you just multiply it by pi over 180. 60 goes into 180, total of 3 times. So that's what we have. We have pi over 3 radians. Well, where is cosine? Basically at this 60, at a 1 to 1 over 2, we're going to put 60 degrees. But it could also be at negative 60 degrees. Which basically means in radians it could be at pi over 3, but it could also be at what's called negative pi over 3. So basically, here's what we have. If we wanted to get to this point over and over and over again, and this point over and over and over again, all I would do is I would take plus or minus pi over 3 and add 2 pi times an integer called n. And that would either get me to this point or it would get me to this point over and over and over again. However, we have to multiply this pi over 3. We have to multiply it by the reciprocal of, I'm going to put plus this 2 pi. So this plus or minus that we're going to have to multiply it by the reciprocal of 2.5 over 2 pi. So let me show you guys what happens when you do that. We'll just kind of start with the first answer, then we'll work to the second answer. The first answer is going to be here. The second answer is going to be right there. So let's go ahead and find the first answer by multiplying it by 2.5 over 2 pi. Just like that. And we will get our first answer. I'll go ahead and erase this so you're not worried about that. You're just worried about this right here. Alright, so let's go to the calculator real quick, and let's take pi over 3. I'll open up parentheses, and I will put 2.5 divided by 2 pi. We get this 0.416, and goes forever and ever and ever and ever, 0.416, right? And what I've done is I've typed in our cosine function. I've typed in 1.2, where that's the height. And you can clearly see the very first time, right there, they kind of rounded it, it's 0.417. Well, where's the second time that Luisa, I believe it's Luisa, yeah, Luisa gets to 1.2? The second time is 2.083. Well, how do we get to that second time? Now, this right here, this is the period, right? So it happens every 2.5 seconds, right? So this happens over and over again every 2.5 seconds. So look what happens when I just take 2.5 and I take away that 0.416 repeating. Look what I get when I take the period and I just take it away. I get my second answer. So if I have 0.416 repeating, which is basically 0.417, that gets me right here. All right. Now our period happens every 2.5 seconds. So if I take 2.5 seconds and I take away that 0.417, that gets me my second answer, which is, let's take a look at it, which is 2.083. All right, so 2.08. If we go back to our previous problem, all right, our previous problem, let's see here, our first answer was 0.6396. Now, right here, if we took 12, like basically we did 12 over pi, all right, so 12 hours, right here, check this out, I took 12 and I took away that 0.6396, I got that 11.4 as well. Alright, so let's kind of review what we have here. Alright, right now we are trying to find, not the first time, we are trying to find the second time that she reached a height of 1.2. And the second time that she reached it, that's the first, the second time was 2.08. So it says to the nearest hundredth of a second, so 2.083, so we're going to put 2.08. Alright, and I'm going to go quickly understand, I'm going to leave this right here. I found my first height. I figured out the right here was 2.5. So all I did was take 2.5 and I subtracted the 0.416 and I got 2.08. Alright, let's go on to our final question here. Here's our final question. It says L of t models the length of each day in minutes in Manila, Philippines, t days after the spring equinox. Here, and t is entered in as radians. So we have this function. It says what is the first day after the spring equinox, that the day length is 750 minutes. So this one time, all we got to do, this is going to be pretty easy. We're just going to try to find not the second day, just the first day. But you know what? We're going to go ahead and find the second day just for fun. In case you get the exact same question, it says, hey, what's the second day? Then you already know how to do it. So, go! 750 minutes, put L of t models the minutes, so we'll put 750. Equals 52 sine 2 pi over 365, there's the period, 365, plus 728. There we go. 728. So all we got to do is we just got to find the first day. And then I'm going to make a little unit circle here just so we can kind of how could we find the second day if we needed to find use the unit circle to do that. So I'm going to pause the video and make a little unit circle. Alright, now that I have my unit circle drawn, we'll go ahead and solve this problem. We're going to take away 728 from this side. We're going to take away 728 from this side. Alright, so let's do 750 minus 728. We get 22 equals 52 sine 2 pi over 365 times t. Next thing we're going to do is we're going to divide everything by 52. Alright, so we're left with 22 over 52. If you want to reduce that, you can. Alright, that'll reduce. We can take half of that, put 11. Alright, put half of that, put 26. Equals the sine of 2 pi over 365 times t. Now this is where we have to take the inverse. I'm going to rewrite it right over here. So here we go. We have the sine of 2 pi over 365 times t equals 11 over 26. So this is where we need to take the inverse. The sine on this side, take the inverse sine over here. So all we have left now, is 2 times pi over 365 times t equals the inverse of this. Now, let me kind of explain, where would you have in the sine? Remember, the sine is the comparison of your y value over to the r value. So let's think about this. If the y value is 11, it's not going to be very high up. So we could have that kind of right about over here. It's not a very good drawing. Let's do my draw. Alright, I'll make my triangle as best as I can. So I'm going to call this distance 11 and this distance 26, and this is theta. And this is where it's positive. I can also have sine positive in the second quadrant, right over here. Try to get it about the same height as best I can. So I can also have it right here. That's an 11, that's a 26, and that's theta. Just remember, this theta is going to be 180 minus whatever we get originally. Alright? So basically 180 degrees minus this. So we're going to start with degrees, and we're going to convert it to radians. It makes it a little bit easier for me to talk about. Alright? Talk about in degrees. So let's go over here. I'm going to take the inverse of sine. I'll do 11 divided by 26. Now that's the answer in radians, 0.437. Let's put 0.437. But in degrees, we have 25.03. 25.03. Let's think about that. Ready? So this angle right over here is 25.03 degrees. Now, if we take away that over here, this angle will be 180 minus that, which will become 154.97 degrees. Now that is the angle over here, which basically means from here all the way across to right there. And then we have this right here. These are in degrees. So how do we convert this to radians? It's very easy. All we have to do is multiply them by pi over 180. So I'll get the radian answer real quick. Alright, so here's our two radian answers. Alright, we have 0.437 and 2.705. 2.705. We'll put 2.705. And over here, what we'll do is we'll put 0.437 radians. 0.437 radians. Okay? Now on this question, it doesn't ask us to solve for the second one, but we're just going to do it anyways. All right? So we'll put 0.437. Now, all you'd have to do to solve for t, here's the second one. Put 2 pi over 365 times t equals 2.705. So to finish solving these, all we have to do is multiply both sides by the reciprocal, which is 365 over 2 pi. 365 over 2 pi. I'm going to come up with two answers. Remember, we only needed the first day, but we're just going a little bit above and beyond in case you get the exact same problem. But they don't ask you for the first day. They ask you for the second time. Not the first time, not day, but first time and second time. So here we go. All right, these all cancel out. And we're left with t. So we're going to type that, find the approximate value right there. And these cancel out to a 1. And we are left with just t, which will be this approximate answer. So I'm going to go ahead and carefully type that into Desmos real quick. All right, so we have, this is our first answer, which is basically 0.437. And we are going to multiply that by the fraction of 365 over 2 pi. We get 25.386, all right? And then we also have this 2.705, 2.705. And we're also going to multiply that by the 365 over 2 pi. We get this 157 point, I'm going to write those down, 25.36. Now, our actual answers, if you actually, by the way, I typed this into the graph, Desmos. Here's our function. I put y equals 750. I adjusted our graph settings a little bit so we could see it. So I kind of put the x values between 0 and 400. My y, I'm scrolling around right now, so I put my y values basically between 600 and 800 to start out. Here's our graph so that you can check it out. There's our first answer. We got pretty close just by estimating. All right, 25.38. Here's our second answer, 157.123. And this is if you didn't round it before. All right, this is like if you used all the decimals. So these are our best answers, 25.377 and 157 point, I'm going to take a screenshot of that. All right, 25.377. 25.377 and 157.123. 157.123. 157.123. 157.123 days. That's how many days, and that's how many days. Now, our particular question said, oh, thank goodness, we get to round our final answer to the nearest whole day. So right here, I'm going to say 25 days. That would be the first time. 25 days. What would be the second time that it would last 750 minutes long? The second time would be 157 days. So this would be the first time. 157 days would be the second time. So once again, obviously you can use Desmos to help you out. You should be able to, I realize it's tough learning from home, but basically you type in the function, you type where it is. This is the first time, this is the second time, obviously. But you can try one, at least try one by hand, see if you can do it without just having to depend on Desmos. But right now, Desmos is a great way to check your answer and check your work. So I'm going to type in 25. Cross my fingers. Come on. We got it. I know that was a long video. I hope you guys have a great day. I miss you all, and I will see you soon, hopefully.